Engineering design, management of change. Establishing a structured, accountable framework for modifications in complex industrial systems. Scope, establishing a discipline of safe and controlled modifications. In the context of complex engineering projects, particularly in high-hazard industries such as oil and gas, change is inevitable. But change without structure, discipline, or traceability poses risks to safety, integrity, and project continuity. The Management of Change (MOC) framework provides a formalized pathway to govern all engineering, configuration, and maintenance modifications, whether temporary or permanent, major or minor, across facilities, infrastructure, and operations. This scope of MOC extends to all instances where equipment, process parameters, software logic, or maintenance regimes are altered from their original design or operational baseline. It recognizes that even a minor tweak, if improperly reviewed, can cascade into systemic vulnerabilities. Therefore, only authorized, justified, and fully documented modifications are permitted under a structured review and approval process. The MOC process bridges engineering, operations, maintenance, and HSE disciplines. It ensures that any modification protects safety and does not compromise operational integrity, considers all technical, procedural, and cross-disciplinary interfaces, preserves traceability and ensures records remain auditable, triggers relevant approvals for exceptional, emergency, or inadvertent changes, integrates risk assessment rigor and documentation control. In doing so, the management of change discipline becomes a guardian of design intent, ensuring changes are not only possible but are executed responsibly, traceably, and in alignment with engineering excellence. Objective: embedding change management as a pillar of engineering integrity. The primary objective of management of change is to ensure that no modification is introduced into a facility without proper evaluation, communication, and control. This principle safeguards both people and assets from unintended consequences, technical oversights, or regulatory non-compliance. The MOC process is designed to prevent unintended safety risks through multidisciplinary technical scrutiny, preserve original design intent by referencing applicable specifications and standards, avoid scope and cost creep by validating justification before work begins, ensure full transparency through traceable, auditable documentation, foster cross-functional accountability across engineering, maintenance, and operations, safeguard the validity of safety cases by maintaining design and operational alignment. This structured approach supports a broader goal: to embed a proactive culture where modifications are not just managed, but deliberately engineered to enhance safety, performance, and resilience. Whether the change involves equipment, instrumentation, configuration settings, or maintenance philosophy, it must pass through a system that prioritizes integrity over convenience and foresight over haste. Engineering design, management of change. Establishing a structured, accountable framework for modifications in complex industrial systems. Identifying relevant modifications, categorizing change to ensure the right level of control. Not all modifications are equal in complexity or consequence. The first step in a robust management of change process is to accurately identify the type of modification proposed. This categorization ensures that the level of scrutiny, technical input, and procedural rigor applied is proportional to the impact and nature of the change. To streamline this, modifications are typically classified into 3 categories, each defined by the nature of the activity, the discipline affected, and the risk posed. Full engineering modifications. These involve physical, structural, or functional alterations to plant equipment or systems. Such changes may include installing or replacing piping, vessels, pumps, or instrumentation, mechanical redesigns, e.g. support structures, bolt specifications, pump seals, alterations that may indirectly introduce risks such as dead legs, drainage issues, or corrosion traps. These modifications usually demand cross-discipline review, revised drawings, hazard evaluation, and formal reapproval. They are governed by the most rigorous pathway in the MOC process. Configuration changes. These are non-physical changes that affect the functional parameters or control logic of existing equipment or systems. Examples include adjusting set points on safety valves, alarms, interlocks, or trip systems, reprogramming control system software or changing logic on a programmable controller, updating the configuration of shutdown, fire and gas, or process control systems. While these changes may seem simple, they often carry high operational consequences and must be validated by competent technical authorities with appropriate documentation and verification. Maintenance modifications. These changes are operational refinements based on observed field behavior intended to improve maintainability without altering system design. Examples include extending or reducing preventive maintenance intervals, modifying the methodology of servicing based on reliability feedback, not changing all seals during every overhaul if unnecessary, adjusting spares strategy based on equipment failure data. These changes are critical for optimizing cost and performance, but must be documented to ensure traceability and consistency within the maintenance management system. Each modification, regardless of type, must be approached with a questioning mindset. What could this change affect? Who needs to know? What needs to be updated? This mindset ensures even the most routine-looking adjustments are subjected to appropriate oversight. By correctly identifying and classifying modifications at the outset, organizations can apply the right resources and reviews at the right time, avoiding both over-engineering of trivial changes and underestimation of consequential ones. This forms the foundation of a practical yet effective MOSI system. Engineering design, management of change, establishing a structured, accountable framework for modifications in complex industrial systems. Roles and responsibilities. Defining accountability across the life cycle of change. A successful management of change MOSI system depends not only on processes, but on people, clearly designated, empowered, and accountable. Effective MOSI execution hinges on assigning roles that ensure both technical depth and cross-functional coordination throughout the life cycle of a modification. To this end, a well-defined structure of responsibilities helps avoid delays, confusion, and safety blind spots. The following roles form the backbone of a disciplined MOC framework. Initiator/originator. Any technically competent individual who identifies a need for change. Their role is to define the problem, outline the proposed solution, and document initial justification. Discuss the proposal with their line manager and secure preliminary buy-in. Ensure the modification is submitted into the MOC system via the appropriate forms. Responsible Job Officer, RJO, appointed by the Senior Technical Authority, STA. The RJO owns the progression of the modification from concept to closeout. They are responsible for coordinating all technical inputs and managing multidisciplinary collaboration. Leading documentation development, statement of requirements, work packs, updates, planning resources and overseeing implementation, commissioning, and documentation. Ensuring records are complete and traceable across all disciplines. Senior Technical Authority, STA. The STA is the technical gatekeeper accountable for ensuring integrity is never compromised. Their responsibilities include reviewing all proposals and determining the classification of change, setting expectations for safety reviews and engineering depth, approving final engineering plans and conducting post-implementation review, guiding the team through decision-making on options, risks, and justifications. Technical authorities, mechanical, electrical, process, maintenance, HSE. Each technical authority reviews modifications relevant to their domain, ensuring the change adheres to applicable standards and does not introduce new risks. All relevant documentation is updated, e.g. P&IDs, loop diagrams, maintenance plans. Constructive feedback is provided in a timely, traceable manner. The final solution is robust and does not undermine safety or performance. Facility Manager, Senior Operating Authority. These roles ensure alignment between modification proposals and operational realities. Their functions include reviewing proposals for operability, safety, and implementation feasibility, approving site-specific implications such as manning, training, or shutdown windows, providing final go-ahead authorization before site work begins, acting as the job champion, ensuring the modification supports business objectives. Document Control Coordinator, DCC Administrator. The custodian of MOSI tracking and records, this role ensures unique MOSI numbers are issued and tracked in the central database. Documentation is routed correctly, status is monitored, and reports are generated. The modification register remains up to date and auditable at all times. Each of these roles is not merely procedural, they are safeguards. By distributing responsibility across subject matter experts, operational stakeholders, and documentation stewards, the MOC process becomes both technically rigorous and operationally practical. Ultimately, roles and responsibilities within MOC are about more than workflow. They are about cultivating a culture of ownership. When every participant knows their place and purpose in the system, modifications become not just managed, but mastered. Engineering design, management of change. Establishing a structured, accountable framework for modifications in complex industrial systems. Initiator-originator, the catalyst of change and the first line of accountability. Every modification begins with observation, insight, or necessity, and the individual who identifies this need is the initiator. As the origin point of the management of change MOC process, the initiator plays a critical role in setting the tone for rigor, clarity, and justification from the outset. The responsibility of the initiator extends far beyond raising a suggestion. Their task is to ensure that the proposed change is properly articulated, preliminarily validated, and formally entered into the MOC system with transparency and technical grounding. Key responsibilities of the initiator include problem recognition and definition. The initiator is responsible for clearly identifying the issue, inefficiency, risk, or opportunity that warrants a modification. This includes gathering relevant data, operational feedback, or engineering evidence that substantiates the need for change. Preliminary validation and internal alignment. Before the modification enters formal circulation, the initiator must discuss the proposal with their line manager and operational leadership, ensure the proposed idea is feasible and not in conflict with ongoing operations or strategic priorities, secure initial alignment that the issue merits further evaluation under the MOC framework, documentation of the proposal. Using the prescribed MOC format, the initiator prepares a concise problem statement and technical summary of the proposed solution, justification for the change, including operational, safety, or cost-saving rationale, preliminary cost and resource implications where possible, engagement with the senior technical authority, STA. The initiator works with the STA to determine the category of change, engineering, configuration, or maintenance, identify the appropriate responsible job officer, RJO, clarify which departments or disciplines should be consulted during the review, ownership of traceability. The initiator is accountable for initiating the MOC with complete and accurate documentation. This forms the auditable baseline from which all subsequent evaluations, comments, and approvals are referenced. Support. During the review process, even after initiation, the originator may be called upon to clarify the original problem statement, respond to technical questions or challenges, provide additional supporting data or field insights to justify the change. In essence, the initiator is both a stakeholder and a steward. They ensure that the MOC process begins with integrity, focus, and technical clarity, laying the foundation for a modification that is not only needed, but also understood, supported, and well controlled. By executing their responsibilities diligently, initiators help ensure that change serves improvement, not uncertainty. Engineering design, management of change, establishing a structured, accountable framework for modifications in complex industrial systems. Responsible job officer, the coordinator of change from conception to completion. The responsible job officer, RJO, serves as the central coordinator and technical custodian of the modification process. Once a modification proposal is initiated and validated, it is the RJO who assumes full responsibility for driving the change through every phase, from engineering definition to implementation and closeout. As the linchpin of the management of change MO system, the RJO ensures that multidisciplinary contributions are integrated, documentation is controlled, and execution is aligned with both project goals and safety requirements. Their role combines technical oversight, project coordination, and quality assurance. Key responsibilities of the responsible job officer include ownership of the modification lifecycle. The RJO is accountable for the complete management of the modification, from initial statement of requirements, SOR, through to commissioning, documentation updates, and final sign-off. They act as the single point of continuity throughout the MOC journey. Scope, definition, and technical alignment. Working with the initiator and relevant discipline engineers, the RJO develops a detailed and technically sound statement of requirements, ensures that the modification scope is complete, feasible, and fully described for all impacted disciplines, identifies design inputs, assumptions, constraints, and interdependencies. Multidisciplinary collaboration and communication. The RJO fosters collaboration across departments by coordinating input from mechanical, process, electrical, instrumentation, HSE, and maintenance functions, routing the SOAR and supporting documents for comment, review, and resolution, responding to feedback, justifying decisions, and updating the scope as required. Interface with engineering and contractors. Whether the modification is executed internally or by external engineering resources, the RJO acts as the technical and administrative liaison, reviews cost, schedule, and deliverables, ensures technical compliance with applicable standards and specifications, execution readiness, and field implementation. The RJO ensures that all preparatory documentation, including drawings, permits, and work packs, are complete and approved. The implementation team understands the modification scope and constraints. Field execution proceeds in accordance with the approved design and schedule. Documentation control and closeout. A key responsibility of the RJO is to ensure that all drawings, operating procedures, maintenance instructions, and registers are updated to reflect the change. Archive all documentation in the central MOSI system. Coordinate final review with the senior technical authority and facilitate closure. Auditability and governance. The RJO is the guardian of traceability for the modification. They maintain all relevant MOC forms, including initiation, reviews, responses to comments, and approvals. Ensure all project information is accurate, current, and auditable. Monitor compliance with procedural requirements, including safety reviews and documentation standards. The RJO's function is not merely administrative, it is integrative. By providing structure, clarity, and oversight, the RJO transforms a change proposal into a fully engineered, safely executed, and permanently recorded improvement. Their effectiveness directly impacts technical integrity, safety assurance, and operational continuity.